All right, so let's see and make sure that you have your piece function defined correctly. So I'm rewriting f of t as two pieces. Remember, if the inside is positive, then I get to just drop the bars. So that inside would be positive if t is 4 or bigger. And since I'm on this interval from 1 to 6, then it's going to stop at 6. So here t is 4 or bigger, and there's me just dropping the bars. And I just turn them into parentheses because, of course, I'll have to distribute that negative sign. And then if it's negative, and I have to think, well, what would make it negative? Well, anything that's less than 4, then I'll have to change the sign, so that's why I put a negative out here. Okay, so I'm going to simplify both of these. This top one is really going to turn into negative t plus 8, and this bottom is going to turn into t, let me think, that'll be a positive, right? So 4 plus t minus 4, it's just turning into t. Okay, so now I'm ready to take the derivative. Pause the video if you are peeking now and see if you can take the derivative of both pieces. So now that I have the derivative, hopefully you got those two values, I'm interested in when is it equal to 0? Well, clearly I can see it's never equal to 0. It's either equal to -1 or 1, so this is a no solution. And when is it undefined? Well, the part where I might be most interested is what happens where it's connecting. And so if I look for 4, if I'm looking at what's the slope on 4 from the left, well, of course, this is the left part. So 4 from the left, the slope has to be +1. And what's happening to the slope on the right? Well, that's the upper piece. And if I look at the slope on the right, I get -1. So I get a critical point because the slope is going to be undefined at x equals 1. And if I look at the graph of this, that graph is nothing more than an absolute value graph. And I know it's opening down because it's negative in front of the absolute value. And my vertex would be h, which is 4, and k, which is 4, so 4, 4. And I got slopes of, oh my gosh, +1 on the left-hand side and -1 on the right, just like it worked out. Whoops, I don't know why I said at x equals 4. I meant at x equals 1, right? I circled it over here. Durr. Okay, so now I'm ready to make a table. So I've got my critical value at x equals 4, and I have my two endpoints of 1 and 6. All three of those have to go into my table. So I made my table. Here was my critical value of 4 that I got when the slope is undefined, and then these both are endpoints. So I don't really care about what's going on with the slope because I'm going to check them anyways since they're endpoints. And so now I want the y value, but I have to substitute into the original function. So if I plug in 4, I get a y value of 4. If I plug in 1, I get a y value of 1. And if I plug in 6, I get a y value of 2. And so the biggest number, of course, is 4. So here's my absolute max at 4, 4. And the lowest number is 1. So I get an absolute min at 1, 1. So simple. So don't forget to check School Loop and see if I assigned you problem numbers to go with this lesson. See you tomorrow, gang.